Lecture 11.4, An Introduction to Partial Derivatives. This is the White Island Lighthouse, 10 miles offshore from Portsmouth, New Hampshire. Here we have the function f of x and y equals 100 minus x squared minus y squared. When we have functions with more than one variable, we can find partial derivatives by holding all the variables but one constant. The partial derivative of f with respect to x is negative 2x. The derivative of 100, of course, is 0. Also, since we were holding y constant, the derivative of negative y squared is also 0. The symbol for partial derivatives is a rounded letter that is different from the regular derivative symbol. Some textbooks do not use the special partial derivative symbol. The second partial derivative of f with respect to x is negative 2. The partial derivative of f with respect to y is negative 2y. Here, x was a constant, so the derivative of negative x squared is 0. The second partial derivative of f with respect to y is negative 2. Note, the partial derivative of f with respect to x is also written as f sub x. The partial derivative of f with respect to x would give you the slope of the tangent in the plane y equals 0 or in any plane with constant y. In other words, how is changing one variable going to change the value of the function? Mixed variables are also possible. We start with f of x and y equals x cosine y plus y e to the x. The partial of f with respect to x is cosine y plus y e to the x. Remember, cosine y is a constant. If we take the partial derivative with respect to y of the partial derivative of f with respect to x, we get the partial with respect to y of cosine y plus y e to the x, which is negative sine y plus e to the x. We could also write f sub yx equals negative sine y plus e to the x. Starting with the same function, we could find the partial derivative of f with respect to y, which would be negative x sine y plus e to the x. In this case, x is a constant, and e to the x is a constant. Now taking the partial of that with respect to x, we get the partial with respect to x of negative x sine y plus e to the x. So now we treat sine y as a constant. and we get the second derivative of f with respect to x and y is negative sine y plus e to the x. Or f sub xy equals negative sine y plus e to the x. Notice that both answers are the same. Claros Theorem says if the functions f sub xy and f sub yx are both continuous on D, then f sub xy of a and b is equal to f of yx of a and b. In other words, it does not matter which partial derivative you take first.